All right. So we have most of the kids. Some are still missing. Aryan is not here. Neil, Sarah are not here, and Rehan is not here yet. No, Rehan is here now. Sunarka is here as well. So this is the first class for Varun. So Varun, welcome to the class. One thing for you to be aware is I request all the kids not to be busy taking notes because everything that we are doing in the class that is recorded. You guys are not recorded, me and the board is recorded. So you don't really have to worry about something getting missed out while I'm teaching something. Okay, so don't spend a lot of energy and time taking notes. Focus on understanding and following the concepts. That's what we are here for. Okay? And I'm assuming everybody can hear me okay?
Yeah.
Yes, sir.
Wonderful. So as I was saying, one of the mommy requested me to use black marker, and I don't have a black marker today, but I have ordered probably 100 of them. So I'll have more markers, more colors to choose from the next class. So let's get started. So in the class yesterday and the day before, or the previous class basically, we started learning about statistics, and I have bored everybody enough to say why do we need to learn statistics. So as far as the practical usage of statistics is concerned, I'm assuming that none of us have any doubt about it. So we'll keep that assumption in place unless somebody comes back to me saying, sir, I'm not clear. And I'm okay going back to the same concept over and over again till you guys are clear, bored and tired of those concepts. Alright, so we'll continue with statistics, and yesterday we started learning some of the tools that we use for statistics. So we started our journey with understanding how do we read and interpret data. That is where we talked about mean, median, mode, and how do we derive those and what is the practical significance of that. And then we moved on to the next stage. What happened to Deep? Deep joined and left. Maybe because I did not greet him. Okay. Hey Deep.
So, like, my internet went out.
No, I thought, no, I did not greet you, that's why you got upset with me and then you dropped. No,
No, it's okay.
if I don't do that, please trust me. I'm just totally lost with math, okay?
Yeah, okay.
Alright, so coming back to, we started learning with about data and understanding data. That is where we talked about mean, median, mode. And then we said, okay, fine. We understand how do we collect data, how do we organize data, how do we derive some behavior out of the data. Then we said, okay, fine. Just understanding, interpreting is not enough. I understood everything. What did Alekya understand? She cannot drill a hole in my brain to figure out what I'm understanding and interpreting. So she has to see what I'm thinking, and that is where the data representation came into play. And we started talking about easy and intuitive ways of data representation. That is where we talked about some of the tools like bar chart, line graph, pie chart. What else? Histogram we did not talk about yesterday. But what else did we talk? So we talked about bar chart, line graph, bar chart or bar graph, line chart, and we talked about pie chart. Which pie? Apple pie, banana pie, carrot pie. Anyways, bad joke. Let's move on. So then we are going to the next thing. So we have few more tools that we wanted to talk about. Hey Gautam.
Yes, sir.
So there are few more tools that we did not talk about yesterday, and they are precisely, one is histogram, second one is dot plot, third one is Scatterplot. Anything else that you guys are able to recall which I am forgetting?
Box plots.
Box plots. So box plots are somewhere closer to histogram and bar graph, but let's see. We'll come back to that because I'll be very honest with you guys. I've not prepared box plot. I've not looked at what exactly box plot looks like. Once you guys explain that to me, we'll try connecting the dots between the box plots, bar graph and histogram and see how does it make a difference to our lives? Is everybody able to follow me so far on the screen?
Yeah.
Okay. And guys, if I'm not calling out anybody's name, that doesn't mean I'm ignoring anybody by any chance. Okay? Any doubt, smallest, tiniest, biggest doubt, don't hesitate. Raise your hand and stop me. So there are three tools for statistics or data representation that we'll talk about. And again, as I always say or insist, I will not just tell you what exactly it is. I owe you guys a reason as well. Why do we even have to worry about this particular tool, and how does it help? How does it make a difference from a practical usage point of view? So let's start with histogram. Does it have anything to do with history? No, right? No. And kids who have spent some time with me, they know that I have a very, very bad habit of cracking dad jokes. Okay, well, that comes for free. Okay, so dad jokes are free. No extra charges for dad jokes. All right, so this is, I'm just drawing something here, okay? So, and I'll give it a name. Let's say 0 to 30, 30 to 60, 60 to 90, and 90 to 100. Okay? And then here 10, 20, 30, 40. What exactly I'm trying to do here? How are you trying to draw a histogram? And it doesn't make any sense so far, and that's okay. Not everything in life makes sense. Some of the things are pretty much nonsensical in nature. Another one, another dad joke. So let's say this is okay. Now let me add some story to it, because so far it is very dry. Whatever I did, I just drew it on the board. Now I'm saying this, I'm calling this histogram, I'm calling this a bar chart. That's what it looks like. But without story, it has no existence. So let me add some story to it. Now I'm saying, wonderful. Here, this one I'm saying, this is a histogram where I have plotted some information, which is, let's say there was a class of 50 students. Anybody feeling hot? We're just a button click away from making it cold. Alright? So, 50 students appeared for exam. One test, let's say math, social studies, US history, whatever. And then, I'm counting, so this one is representing how many kids got 0 to 30. I'm not giving exact figure. I'm saying kids who got 0 to 30. Let's say the total test was for 100 marks. Kids who got 0 to 30. Now I'm giving you a little more clue. I'm saying this is the marks range. And this is number of kids. Number of kids. So, here, if you look at this, this is building kind of a story now. What if I read this graph in my own way? I'll say, okay, there were around 22 or 23 kids who got scored from 0 to 30 out of 100. There were around 30, maybe 33 kids who got scored between 30 to 60. And there were around maybe 29 kids who got scored from 60 to 90. And there were probably 20 kids who got scored from 90 to 100. So I said that there were 50 kids, maybe I was wrong. Here you should read this. This is maybe 23, this is 32, maybe this is 29, and this looks close to 18. So now this is 50 plus 52, maybe 102 students. This small 4 by 4 or 6 by 4 diagram is giving the complete view of what happened to 102 students in a test. Okay? And not everybody got perfect match, right? Let's say one kid got 72, other kid got 71. Imagine if I have to draw a bar for every score. I'm talking about 0 to 100. Imagine how cluttered this bar graph would look like. I'll say student 1 at 29, okay, this is one bar. Student 2, 36, the other bar. Student 3, 79, another bar. And now I have 102 students. Look how cluttered that would have looked. Probably one A4 sheet would not have been sufficient for drawing it. However, knowing the behavior of the data that I'm looking at, I'm not really concerned about 71 versus 72 versus 74. I'm more concerned about 40 versus 75 versus 3 versus 99. Correct? So that is why when you're dealing with a range of record, histogram plays an important role. When you're looking at absolute values, let's say if I say in the month of May, let's say if I have to plot average temperature of 10 months or 12 months in a year, I can as well put 12 graphs, 12 bar charts, 12 bars. Every bar representing the average temperature of the month, and it will still be readable. It will still be readable. I might have to squeeze in the font size a little bit, but it will still make sense. But if I have to plot 1 month's 30 days temperature, if I put 30 bars, not a great idea. Instead, what I will say is, okay, fine. Let's see how many days has the temperature ranged from 45 to 65. How many days had temperature ranging from 66 to 79, and then how many days it went beyond 100. I have three adjacent bars which I will call histogram because they are contiguous in nature. And I can focus on, okay, these are my hot days. These are extremely hot days when probably schools might want to give holidays, right? So, end of the day, every tool, every statistical tool that we use, they have a purpose. And the only purpose they have is, they want to deal with large volume of data, but they still want to represent that in a more intuitive, simpler way, so that it makes a lot of sense to anybody and everybody who is as less intelligent as me. I keep claiming that I'm not very intelligent, because the day I start pretending I'm intelligent, I will swallow a lot of things. I will not be transparent with you guys. So I have to always keep that thing in mind, that I'm not intelligent. Okay? If some of you think otherwise, that's okay. That makes you feel good. But I will not pretend to be intelligent. Is that fine? You guys don't answer difficult questions. Okay, so coming back to the point. So now, based on whatever you saw, if I draw a simpler picture, this kind of a situation where you see the bars are actually neighboring each other, adjacent to each other, where represents contiguous data range, that is histogram. When you see bars being like my house and my neighbor's house, there's some gap, there's some area to do lawn mowing for. These are bar charts. And there's a reason. Now, at any point in time, we should not be confusing ourselves with respect to when to use histogram versus when to use bar chart. When you have point blank data that you want to talk about, and then it is not going to make it very cluttered, you might want to instead look at bar charts. When you're talking about large volume of data, where we are not concerned about one particular data, you're concerned about the range of data, good, average, very good, excellent kind of a thing. You might want to deal with the range, then you will go with something called histogram. Though physically they look similar, bigger houses, smaller houses, more land in between, bigger houses, no land in between. Yeah, they look similar structure wise, but there is a different purpose for it. Time for me to go muted. Any questions? Gautam, Dhanushri, Ria, Dev,
No, sir.
Rehan, Anvin.
No, sir.
Varun, how is your first day?
Pretty good.
Pretty good. Okay. And if I'm boring anybody, if I'm getting anybody tired, please let me know. I'll try adding some more spice to the way I teach. Okay. All right. Rehan, okay. Chris and Vishal, okay.
Yes, sir.
Okay. Cool.
Yeah.
So far we have looked at one more tool that we called histogram, and our understanding or interpretation from that was histogram is a tool, a statistical tool that we use for representing data. We are dealing with not exact values, rather you are dealing with ranges. So now let's look at this with a very mean view of a teacher. Let's say this is a very mean teacher you're dealing with. Okay. Thankfully, I'm not one of your class teachers, so even if I say somebody is mean, I'm not pointing at myself. Now look at this. When the teacher looks at it, okay, and he or she has to find a favorite. Okay. So this is 0 to 30 in a test. Okay. This is 0 and this is 30. This is the range. This is 31 to 60. 60. And this is 61 to 90. If the teacher has to pick up a favorite, ideally teacher should not, but in case he or she has to pick up the favorite whom they want to kind of project for something big, they will pick from this range. They will not go and hand pick Alekhya. They'll say, okay, Alekhya, Arush, Tansi, Pranit, okay, in this group, okay. This is my group of favorites. I'm just making it up. I mean, don't anybody on the screen don't get offended, okay? That was just just another joke. Now, let's say if you all want to be in the list of favorite for the teacher, you would say, okay, I would want to be part of this chart, right? And so look at this whole thing. One chart called histogram. Two different set of people have two different perspectives. That is exactly what it is meant for. Teacher is okay, this is where I will find my students. You all will say, this is where I want to be. So there's a lot of story. There's exactly a lot of story. And that's why even if I claim to be a math teacher, I insist on story part of it because that gets stuck. Alright, so histogram, bar graph, pie chart, and line graph. Clear so far? Dhanushri, clear beta?
Yes, sir.
Sunarka?
Yes, sir.
Sunarka?
Yes, sir.
So my obvious pick are students who stay quiet. Because that's where I get worried. That, okay, somebody is not speaking up. Maybe because I'm not explaining it well, or there's a bit of confusion. Okay. So if you don't want your name to be called out, keep responding to my questions. Okay. All right. Now let's go to the next one. That's called dot plot or scatter plot. Gautam, are you with me so far?
Yeah.
Okay. Now we're talking about two more tools called dot plots and scatter plots. I'll come to scatter plot a little later. Now let's look at dot plots. How many of you eat fruits? Most of us, yeah. Okay. I mean, even if you don't, please say yes because that's getting recorded, okay? Okay. Now, I say, I want to plot something like, I picked up, let's say 20 kids, all from my class. Say, okay, let's see who is eating how many fruits every day or how many times every day. Okay. So I found that some kids I picked up 20 students, some kids are eating fruits only once a day. Okay. Some are eating twice, some are eating fruit 3 times, some are eating fruit 4 times. Okay. And some are as crazy as me who keeps on munching fruits every 1 hour. I love fruits. So, what I will do is, now I have again a different range. So I can say, okay, 0 to 3 fruits per day, I will put a histogram. 3 to 6, I'll put another graph, another bar. 6 to 9, another bar. Or I can say, okay, fine, I have only 1, 2, 3, 4, 1, 2, 3, 4, 5 categories. Okay, let's say 1 fruit a day, 2 fruit a day, 3 fruits a day, or 3 times fruits consumed a day, 4 times a day, and 10 times a day. And then I picked up Dhanusri. Dhanusri said, okay, I eat fruit 3 times a day. Okay, done. Rehan said, I eat fruit 4 times a day. Okay, I put another dot for him. Alikya said, I eat 2 times a day. Okay. These are not legitimate data, okay? These are all made up. Now, Tansi said, okay, I am eating 10 times. I love fruits. And then Gautam says 4 times. Then Nikhil says 3 times. Then Vishal says 4 times again. Then Rehan says 4 times. Then Ritika says 4 times. Then I found one more student who's as good as me when it comes to eating fruits, Savya. Then Varun says, I also eat a lot. Okay, I'm wasting everybody's time. Now here, so I did not plot for everybody, okay, just picked up some examples. Now by looking at this, this is called dot plot, where you use certain parameters against which you measure the frequency. So essentially, if you look at the y-axis, it is just a placeholder. These are the occurrences. These are the data elements against which you are measuring the frequency. Again, this looks very intuitive. Just by looking at this, let's say there's a doctor who's looking at this information. It's okay. These are going to be my set of very healthy kids, and these are never going to fall sick unless these two need to bump up their consumption. So again, dot plot is another way of representing it depending on the amount of data that you're dealing with and any particular frequency that you want to kind of grab and then interpret. Dot plot helps you with that. Any questions with this one? I'm kind of a person who doesn't like this graph much. Not because it has anything wrong with it. This is way too simple. It is a very simplistic representation of a small set of data. You would not use dot plot when you're dealing with 100 records or 500 records. That becomes a very tiring exercise and it doesn't really give you the outcome with the effort that you have put in. So that's why I don't like this guy. Not that I have any bias or any hatred for this guy. I see, okay, this is just a piece of information that we need to be aware of. So that's why I'm kind of trying to get a closer on this one quickly so that I get to something which is more interesting. Are you guys with me? Chris, Gautam, Vishal, Varun?
Yeah.
Okay, let's move on. So now we are going to the next one that is called Scatterplots. Now, so if you should relate to what the point that I made, saying dot plot just doesn't help you with a lot of data information. You mostly use dot plots when you're dealing with frequency of certain type of records. For a much more simplistic representation of that data, that's why we use dot plot. Now, that means I'm very keen on dealing with data which is see how playful I am. All the dots are scattered. Now, this is so much of dot. I can keep on making it more and more and more clumsy more cluttered, more dense. This is called scatterplots. Now, why would you have something as messy, as cluttered, as clumsy as this? Yeah.
You can easily find the trend if you're doing.
Mm-hmm. Yeah. You're 2 steps ahead of me. So okay. So when you first thing is when you're dealing with huge amount of data. Now imagine, let's pick up one school district that you guys are part of. Everybody in Frisco School District? Prosper. How about you, Rajesh? Prosper. How about you, Prosper? Everybody, Prosper School District. How about you guys on the screen? Same, Prosper. Salina, okay. We are covering half of BFW, that's good. Gotham. Same, Salina or Prosper. Which school district you are part of?
I live in Plano.
Plano. Okay, so Gotham and Dhanushri are from Plano School District, right, Dhanushri?
I'm from Frisco.
You are from Frisco, okay. Anyways, that doesn't matter. What I was saying was that, let's say, somebody picks up all the students from Plano, Frisco, Prosper, Salina, and some cities in Illinois also. Now you have 5,000 records, let's say, and that is what makes it clumsy. Here, and this is the average CGPA, okay? CGPA of students, let's say in 10th grade. I'm talking about, let's say, 1,000 records. So here on the x-axis, I'm talking about CGPA 2, 2.5, 3, 3.5, 4.5, 5. Here I'm talking about 9th grade first semester, 9th grade second semester, 10th grade first semester, 10th grade second semester. I'm just making it up. So, and these are students, okay? So, or I'll say, okay, yeah. So, if you look at this area, you see this looks very light. If you look at this area, this looks kind of little more dense. This looks very rare, very thin, very light, not much record. What does it mean? If I read this data, I can build a 4-paragraph story out of it. Now, what will be my storyline? I'll say that I see that among the 4 school or 5 school districts we looked at, the average CGPA is around 3.5 in the 9th grade second semester. There were some students who had more also, right? 4.5, but that is not the average. That is some small percentage of students who had higher CGPA also. But what we are seeing is, by the time kids go to 10th grade, first semester, everybody starts leaning towards CGPA 4.5 and more. So that is one part of the storyline. Second thing is, I am saying that even there are some exceptional students who are getting even 5 CGPA in the 9th grade first semester itself. But those are outliers. This one, and there are some students even in 10th grade second semester are getting 2 CGPA. Okay? So these are outliers. This doesn't define the trend. What is defining the trend? Whatever you have in the central region. Now, you might visualize that, okay, if I draw a line which cuts across a good amount of data, that gives me a trend. That will be this line. What do we call this line, guys? I'll come to you later. Let me see who is telling me the answer on the screen. Yes, Chris.
It's the line of best fit.
Line of best fit, okay. And why do we say so? Anybody else, not Chris. Somebody explain that to me like a story. Yes, Nikhil.
So the entire dots, the entire data, the line of best fit represents the most common trend in the entire thing.
Exactly. So this gives you the trend. See, nobody is interested in who is that person A with name Birendra Kumar who got 2 CGP in second semester of 10th grade. Okay. Nobody is interested in knowing my name. When they are looking at 5,000 records, what is my existence? Let's say if I was one of the students. Nobody is interested in my name alone. Because people are looking at this data to derive some meaningful information out of it, which can be further externalized. Data is not only for, it's not like a newspaper where you read it and forget it. Okay. The data, people, there are new jobs that has come, right? Data scientist, data analyst, whatnot. What do? Do they mine data? Do they create data? No. They analyze data and derive some meaningful outcome from that and then use that for some interesting actionable items. Just as an example, let's say you all know how huge Walmart is, right? 8,000 plus stores worldwide. And every store is humongous in nature and size. Now, stores in US versus stores in China. I'm just giving two countries' name. When they keep on selling products throughout the year, but they see that certain products like the candies, they sell the candies whole year. But when it comes to Thanksgiving or Halloween, the sale of candy increases. And that they have in their records because they have seen it happening every year. They will look at the data, okay, how much was the sale of candy last year between October to December versus the year before, and then based on that they relate it, say okay fine, this year if we want to be ahead of the game, sell more candies than target, then will start stocking the candies maybe in September itself and give some offer to parents, say okay fine, if you want to buy early you get for discounted price. So they look at all this data, this kind of huge humongous data, find out the line of best fit and then read that data to make some meaningful interpretation out of it. Is everybody able to relate to what I'm saying?
Yes, sir.
Yes, sir.
Sunalka,
Yeah.
Dave, Ritika, okay. Dhanushri,
Yes, sir.
Shravya,
Yes, sir.
okay. Shravya is you are one of the most quiet kid, okay? So that's why I keep on calling out your name. Never with the intent of putting anybody on the spot, okay? Trust me. Okay, now, and that is another thing, okay? I'm trying to build you guys in a way that you guys become good at telling stories. Because what you know would be known to others only if you are able to articulate that. And that articulation will come only when you build that solid ability for telling stories. If you do that, even if you know this much, if you can articulate well, you'll be known for this much. If you know this much and you don't articulate, you'll be known for this much. So don't become a victim of that trap, okay? Alright, so now just seeing one messy diagram doesn't mean much. Now let's look at two things in parallel. So I'm talking about, let's say, this is again something that is relatable for you guys. This is a score of kids in different subjects. Okay. This is 30, 60, 90, and based on the age. I'm just randomly picking up 20 kids, 40 kids, 60 kids, 70 kids in my neighborhood. I'm saying based on the age, if I conducted a test of math, how much people got, okay? Now look at this graph and this graph, and assume we are dealing with similar data. Okay, so that I don't have to keep on cooking up stories after stories. I'm saying that this is the data that is coming from my neighborhood. This is the data that is coming from Avondale. You guys know where is Avondale? Nearby Avondale. Okay. So I'm saying this is the data coming from my neighborhood. This is coming from Avondale or Richwoods. Now, in this case, again, like you guys explained, that this central region of the data is giving me a view that my line of symmetry is somewhere in between, and that seems to be an increasing trend, meaning with percentage increasing, age increases. Or if I had put age here, percentage here, it would have been same way. It's an increasing trend. So when this parameter is increasing, this is also increasing. What is happening in this case? Yeah.
It's a little bit more irregular. It's like decreasing a little bit more.
So here, if I try drawing the line of best fit, I was trying to draw a line. I ended up drawing a curve or something like a parabola or half of a parabola. If I would have extended that further, it might have become like a parabola itself. So here the line of best fit is, this is much more linear. This is quadratic or non-linear in nature. So every scatter plot that you deal with is not going to be a linear distribution of data. It can be linear, it could be non-linear also. And now you can relate that with your understanding of basic algebra, where you'll say, okay, fine. In this case, my line of best fit is an increasing trend. It's a linear increasing in nature, meaning when one of the parameters is increasing, the other parameter is also increasing. Here this is more quadratic in nature. This is non-linear. I don't know whether it's increasing or decreasing. In case of a non-linear thing, it's never increasing or decreasing. It is increasing, it is decreasing up to here, up to this point, and then it is increasing this way. So it fluctuates. So a parabola gives you flavor of both worlds. It can be increasing up to a certain point, it will be decreasing up to a certain point. Okay? So whenever you're dealing with a non-linear distribution of data or a non-linear scatter plot, you are looking at both the possible flavors or different possible flavors. Is that making sense to everybody, or?
Yes, sir.
Making sense? Mandeep, is it making sense to you, beta? I'm talking about non-linear distribution. Mandeep, you are 8 minutes early, not 8 minutes, you are 20 minutes early for the class, and that is why you will end up scratching your head to figure out what exactly this old man is talking about. So join after 20 minutes, Mandeep, okay? Otherwise, you will start.
Okay.
So you're 20 minutes early, beta, okay? Join at 4 o'clock. Okay? Alright. So he's from level 1. Poor 4th grader, if he has to deal with this. Yep. Mandeep, after 20 minutes, okay? So right now, what we are looking at is scatter plot. So first difference that we started with was dot plot is mostly when you are dealing with smaller number of data and you are more interested in knowing the frequency of certain records. Let's say you look at, assume, you guys don't walk to school, but in our days we used to walk to school. So there are 10 kids who are walking to school. You want to figure out how much time one child takes for walking to school every day. You put the dot plots. Okay, day 1 took this much, day 2 took this much, day 3 took this much, and then it gives you a view of, okay, is it standard or is it fluctuating? So based on that, you can derive some interpretation out of it. So dot plot is primarily for dealing with small set of records where you are able to derive the frequency of certain records and take some meaning out of it. When scatter plot is primarily when you're dealing with large volume of data, and from that large volume of data, you're trying to find out what is defining or what is that line along which it is very symmetrical. This guy is not falling on this line of best fit, but pretty close. So even if this guy is not on this line, but he's certainly not a stepchild. Who is the stepchild here? This guy. They are called outliers because they don't have any influence on this trend. They are just existing because of their existence. They have no say in everything that happens here. When these things are actually averaging out to give you this line of best fit. So here in this case, we are looking at a scatter plot with an increasing trend. You might come across a scatter plot where it will plot data like this, and then you are seeing a decreasing trend based on what you see here. See, with data increasing, this parameter increasing, this parameter increasing, this one is decreasing gradually. So this is a line of best fit. So this is a decreasing linear scatter plot. This is an increasing linear scatter plot. This one is non-linear. And again, you will look at your data and you will try to kind of put a line which just sneaks through the majority of data. That gives you the, yeah.
Isn't it possible to have like not have a line of best fit because it's like the data is very dispersed? There's
You have to say it a little louder for me.
isn't it possible to have not have a line of best fit because your data is like extremely dispersed? And
That's fairly possible. See, ultimately, you are making my life difficult. I'll tell you why. Mine isn't any teacher's life difficult. So ultimately, any data that we look at, what is the purpose? The purpose is to look at it, consume it, derive some interpretation out of it. Now imagine this scatter plot, okay? It's all over the place. So then you end up doing a compromise. Compromise as in, okay, I wanted my line of best fit which kind of is closer to 80% of my data. Okay, that is not possible, but I see some density in the middle. I cannot achieve accuracy to the extent I wanted, but yeah, if I pick this is a line of best fit, I am only talking about 10% of the behavior. If I am looking at this line of best fit, I am talking about maybe 15% of the overall behavior. I will still go for a trade-off. This line is somewhat 35%. Okay. Best among equals. Yeah. So any scatter plot that you talk about, you will end up going for a trade-off which gives you maximum possible coverage. You would not say, okay, I will go for this as my line of best fit, because this has no relevance when it comes to this data that we're talking about. So you go for the line of best fit. You can probably add a word in between saying line of best possible fit to practically relate it. Ultimately, you're trying to see, okay, what is that line which is providing the maximum possible coverage? It might happen that we are always thinking line of best fit, but if you go this way, you are probably covering 45%. This becomes a non-linear distribution. So it's always a trade-off, and how you want to interpret this information and relate it to have maximum possible coverage and be able to use that information to derive some interpretation out of it. So everybody on the screen, I'm just repeating the question that came. That is it possible that I have a scatter plot without a line of best fit? And my answer is probably not. You will still try to find out, go for a trade-off which gives you maximum coverage with respect to the data that you're looking at. Does it make sense, Vishal? Vishal was not ready to answer. How about you, dear? Does it make sense or it doesn't? Dave?
Yes, sir.
It does? Okay. Rehan? Okay. Ritika, is it clear?
Yes, sir.
Okay. So, we talked about all the possible tools that we know of. And when it comes to plotting any tool or choosing which tool you want to go for, it will depend on the intent and the content. Content as in the data volume, intent as in what you are trying to demonstrate. Based on that, you will take a call. Okay. Now, drawing these charts or graphs, it's very easy. You have to first always look at what is that you are trying to achieve, and then how would you put your data together to use it for the given purpose. So I have put some questions yesterday. Let's see if we can pick one of them and try solving it. Okay, it could be relating to any of the graph or the tool that we have talked about. So let's look at one of the question and see how would we go about it. Okay? So I have put a lot more questions, and I'm assuming that all of you, right, after the class, whenever we learn some concept, make sure that you go to Khan Academy, pick up that particular unit or section and try doing the unit test. Okay, not because there is any stress I'm trying to build for you guys. I want you guys to challenge me. I want you guys to, whatever you have understood in the class, go open that chapter, do some unit test and see if you're able to solve it by yourself or not. If you're not, that means there are two things. Either you did not pay attention in the class, or I did a very bad job of explaining the concepts. And in both the scenarios, it is to be done. If I did not do a good job, I have to redo it, explain to you guys one more time in a better, simpler way. Or if you did not pay attention, there's a video for you, just watch it one more time and then try doing it. Okay? Is that a fair assumption, Varun?
Yes, sir.
Okay. So I know post lunch on Sundays it could be a little sleepy. That's why I'm trying to purposefully wake up everybody. Okay. Now I'm reading the question. Okay. One of the questions we'll try solving together. Paulina bought her first video game in 2014. The line graph above shows. There's a line graph. Let me draw it the way I'm seeing it. Okay. 1, 2, 3, 4, 5, 6, 5, 10, 15, 20. 1, 2, 3, 4, 5, 6. Paulina bought her first video game in 2014. Okay, let me draw it also for you guys. This is a graph, okay? Now I'm reading the story part of it. Paulina bought her first video game in 2014. Okay, wonderful. The line graph above shows the total number of video games Paulina owned since then. She bought her first video game in 2014. The line graph above shows the total number of video games Paulina owned since then. According to the graph, the number of video games she owned in 2015 is this says years since 2014. Okay, this is the horizontal line says years since 2014. So this is 1, this is 2, 3, 4, 5, 6. Now I'm reading the question one more time. It says Paulina bought her first video game in 2014. The line graph above shows the total number of video games Paulina owned since then. According to the graph, the number of video games she owned in 2015 is what fraction of the number she owned in 2019. So, you guys got logged out. Let me unlock you guys first. Okay, did everybody hear the question? So this is my first and the most boring thing, right? Read the question again and again. So I'm reading the question for you guys one more time so that you all get it. This is a graph that is given to you where on the horizontal axis it says years since 2014. 1, 2, 3, 4, 5, 6. And then on this side you have 5, 10, 15, 20. This is number of video games. So now this graph, if I'm reading the question, says Paulina bought her first video game in 2014. This is when she bought her first video game. The line graph above shows the total number of video games Paulina owns since then. Total number of video games. So this is probably one, okay? This is when she bought her first one. This graph shows the number of video games she owns since then. According to the graph, the number of video games she owned in 2015 is what fraction of the number of numbers she owned in 2019. You just have to read this graph. So I'll just make it a little easy for you guys to read. This is 5. This is somewhere around 9. This is somewhere around 11 or 12. 5, 9, 11. And this is probably 15. And this one is 20. So the question, yeah, saying something?
It's like
Okay. No, don't be shy, it's okay. If you give me a wrong answer, I love it. So be brave to give me a wrong answer as well. Now I'm saying, if you want to give an answer that goes wrong, I don't mind. I'm perfectly fine with that. I just want you guys to think. Can I assume everybody is thinking about it or is able to see what is there in the question? Or anybody has any doubt?
No, sir.
You're clear? So, what would be your answer? And do you guys know what we are trying to figure out? Can anybody tell me what we are trying to figure out? I'm reading the last line of the question one more time so that there is no doubt. According to the graph, the number of video games she owned in 2015 is what fraction of the number she owned in 2019? How many video games she owned in 2015? Any idea? I'm sorry? 2015? 2015. I'm sorry?
5.
Okay, yeah. So, years in 2014. So, this is 1 year. So, 2015. This is what she had. 5 video games she had by 2015.
I think I know the answer.
Okay, what is the answer?
1/3.
So, this is 15, 16, 17, 18, 19, right? And you saw that in 2019 she had 15 video games. In 2015 she had 5 video games. So, the question is, the number of video games she owned in 2015 is what fraction of the number of she owned in 2019? So 2015 by 2019. Yep. So see, now many of you must be thinking that this is a very easy one. And why we are actually doing it? We are doing it because I want to make you guys believe that actually statistics is the easier one. Okay? All the complexity lies only in the storyline of it, or the word part of it. If you decode that, if you read that in detail, if you understand that, interpret it, or read it enough to understand what exactly it's asking, this calculation is much more fun because everything is given to us in a very intuitive way. That's what these graphs are meant for. So as long as you decode the question from the words, the paragraph that you are given, and you read it correct, you don't need me. Yeah? With that being said, any questions? Guys, sit down. Nikhil and Anika, stay in the back. Wait for your turn. We still have 3 more minutes. Nikhil, wait there. Okay. So, any questions?
No, sir.
No? Then you guys are good to go. You sailed through the 2 tough days of your life dealing with me. Have fun.
Have a good evening, sir.
You as well.
Bye.
Yeah. Alright, bye bye. Take care.
Thank you, sir.
Yeah, alright, bye bye.
Yes, sir.
Yeah, bye bye.